Hello children, motion, class 9, subject science, chapter 8 and this is the part 1. So in today's class let us study about describing a motion. So when do you say that object is at motion and when do you say that the object is at rest? Okay, so let us discuss about all these things in today's class. So before studying about the object at rest or object at motion, let us look at few motion which we are going to observe in our daily lives. Okay, so in that people walk, birds fly, fishes swim, buses ply, planes fly and ships traverse the oceans. So these are few real-time examples that we see in our daily lives, right? And when it comes to the moon and planets, the moon and the planets move around in their orbits. We all know about it, right? And we also observe natural phenomena such as water flowing in a river and falling down a waterfall, and falling raindrops and flowing wind. So these are few natural phenomena that occurs, right? So where the motion is occurring, like water flowing in a river. So the water is flowing. So water is in motion, right? So like that we observe few natural phenomena. And the hands of a clock move around to show us the time. So what happens? Have you all observed the watch? Yes or no? So what happens in that? The hands of the clock moves, right, in order to show us the time. And animals move in forest for their food and water. So these are few daily life example of motion. So describing position of objects. So position is always relative to an origin and in a frame of reference. It could be in 1 or 2 or 3 dimensions. So what do you mean by relative? Relative to an origin and in a frame of reference. For example, a person traveling in a train feels that the trees or the surrounding is moving, right? Whereas what is the in real time, what is happening? It is that the train is moving, right? So it is always relative in with respect to the reference. Okay, and let's look at few examples for 1 or 2 or 3 dimensions. So for 1 dimensional, the example is like this. The ant is on the edge of the wall, that is 20 centimeter from the corner. So what happens? So the ant is on the edge of the wall, so which is 20 centimeter from the corner. So it is with respect to 1 dimension. Therefore, it is an example for 1 dimensional. And next coming to the 2 dimensional. So the tree is 15 meter to the east and 20 meter to the south of the center of the school ground. So here with respect to 2 dimension, the tree is defined, right? So therefore it is an example for 2 dimensional. And when coming to the 3 dimensional, the kite is at 2 meter north, 3 meter west and 10 meter high with respect to the boy. So here in 3 dimensional, the kite position is defined. Therefore, it is an example for 3 dimensional. Next, describing motion. So motion means what? So motion is change of position with respect to the time. So if an object is moving from one place to other place in some time duration, then the object is said to be in motion. Okay, so if the position of an object does not change at all, then the object is at rest. Okay, so if, for example, let's take a time like 3:05. So from 3:05 to 3:30, if any object does not move, then the object is said to be at rest. So example, a tree in the playground. Will the tree move from one place to other place? No, right? So it is an object which is at rest. Okay, so if the position of an object does not change at all, then the object is said to be at rest. So if a snapshot taken at 2 time instance, say T1 and T2, shows an object at different positions in the 2 snapshots, then it has moved. Which means what? Say time T1. So at time T1, if an object is at some position, okay, and at time instant T2, if the object has moved to some other place, which means that the object has moved. So therefore, time plays a very important role, okay, to describe whether an object is at rest or motion. Next, coming to the displacement. So what do you mean by displacement? Displacement describes where the object is at the final instant with respect to where it was at the initial instant, which means irrespective of the distance it has traveled, displacement only describes about the final instant with respect to the initial instant. It does not bother about the distance traveled by that object. Okay, it is just the initial instant and the final instant. So whatever is the distance is called as displacement. Okay. And next, coming to the vectors and scalars. So physics deals with many physical quantities which are divided into scalars and vectors. So what do you mean by scalar? So let's take few examples here. Distance, time, volume, mass and temperature. So all these things, they give us only the magnitude or the single number. For example, so the distance traveled by an object is say 20 kilometer. So it is just the 20 kilometer. It represents only the magnitude. It does not represent the direction. So that itself is nothing but the scalar quantity. Okay, so a scalar quantity is one that can be described by a single number including any units, so giving its size or magnitude. So scalar quantity represents only the magnitude. Okay, whereas what about the vector quantity? So a vector quantity requires specification of both magnitude and direction. Okay, so scalar represents only the magnitude, whereas the vector represents the magnitude as well as the direction. So example, so displacement. Okay, so displacement means what? So the object has moved 10 kilometer towards the east, say, which means it is also specifying the direction along with the magnitude. So here are few examples for vector quantity, that is displacement, force, weight and velocity. So these all comes under the vector quantity, which means it requires both magnitude and direction. So distance and displacement. This is a very good example to understand the distance and displacement. So starting from origin O, a person walks 90 meters towards the east, then turns around and walks 40 meters west. This is an example of one-dimensional motion as it occurs on the east-west line. So displacement is based on just the initial and final position, whereas the distance traveled is calculated along its entire path. Okay, so what happens? So from origin O, a person walks 90 meters towards the east, as you all can see, 90 meters towards the east. And then what happens? He walks 40 meters to the west. Again, he takes a U-turn and comes to the west and reaches some position, say B. Okay, so it has moved 40 kilometers towards the west, right? So in this example, so the distance traveled is 90 plus 40, which is nothing but 130 meters. Okay, and it represents a scalar quantity because the distance traveled is a scalar quantity, right? Whereas what is the vector quantity? What is the displacement here? So the displacement is what? It is just the initial and final position, right? So the initial position was O and the final position is B here. Right? So it has moved 50 meters towards the east. Okay, why it is towards the east? Because from O it has moved just 50 kilometers and it has reached the point B. Irrespective of whatever the object, whatever the person has moved, that is say 90 meters towards the east and then the 40 meters towards the west, it is just representing only the initial and final position of the object. So the initial position was O. So how many meters it has moved? It has moved 50 meters towards the east, and it is a vector quantity. Why? Because it is representing the direction also. So what did you learn in this video? So we have learned about the defined position of an object, reference to an origin. So motion is a change of position with respect to time. Motion can be 1, 2 or 3 dimensions, and the distinguish between scalar and vector quantities. So we considered motion in one dimension where the object moves only on a straight line. So distance traveled is a scalar and is the total of all movements whether to the left or right. Displacement is a vector and it specifies the final position with respect to the initial position. So here are few questions that you have to answer. Okay. So motion is change of position with time, true or false. Displacement is a scalar. True or false? An athlete ran 3 full rounds on the ground and returned to his starting point. So what is his displacement? So here you have to calculate the displacement. Displacement means what? It is just the distance between the initial and final position. A ball is thrown up from the terrace of a building. It goes up vertically a distance of 20 meters before falling down vertically a distance of 30 meters. So what is the total distance traveled and what is the displacement? Okay, please answer all these questions and then look at the answer. So I have attached a answer slide also in this end of this video. Okay, please answer and then watch it. Thank you, children.